of you?
No, sir. I've already joined before.
But I didn't see you because of past 1.5 months I'm teaching now.
Yes, sir. I was having exams, so I couldn't attend.
Okay, so that's why you didn't attend my classes, huh?
Yeah,
Okay,
sir.
1.5 months I'm seeing you, that's why I got it out. So in which college you were studying?
Suman Junior College, sir.
Suman Junior College.
Yes.
Okay, ma. So you which standard you? I thought you were the 11th standard or 12th standard?
12th, sir.
12th. Okay, good. So nice to see you. Nice to meet you. Okay.
Yes, sir.
So 12th standard means portions are completed. Still any portions are there, ma?
I didn't get you, sir.
So your 12th portions are completed. Or still any portions are there? Any
No,
topics are
sir.
there?
No, sir. Every subject completed.
All subjects are completed. Chemistry also is completed, huh?
Yes, sir.
Okay. So then, so because of yesterday only, I started some solutions chapter. That's why I'm asking. Because of this is the neck of the moment, na. Hope so everyone they may be completed their syllabuses. Hi,
Okay,
Kathy.
sir.
Kathy, good evening.
Good evening, sir.
Kathy, can you respond?
Yes, sir. Hello.
Are you getting my voice?
Yes, sir.
Okay, ma. Ma, yesterday you didn't attend my class, Kathy.
Sir, I had other classes in that time.
Okay.
I can
Okay.
attend from now, sir.
So chemistry also is there, na? That's why I'm asking.
Yeah, sir. Past 3 days, I had other classes during this time, so I couldn't
Yeah,
join.
you missed my class.
Yes,
Okay.
I saw
Anyway,
the
once
recording, sir.
yeah. Okay. Ma. So anyway, once again, I'll revise yesterday's class just for briefly 5 minutes here. Okay. In
Okay.
yesterday we were discussing about the solutions, ma. Actually, what is meant by the solutions means here? Solution is a mixture of components. Solution is nothing but here mixture of components. Sirisha, whoever they absent yesterday, all are there logging today. Hi everyone.
Hi, sir.
Okay. Anyway, so once again I'll revise the yesterday class. So yesterday we were discussing about the solutions chapter, ma. So what is meant by the solution means? Solution is nothing but it is a mixture of components. What is meant by the mixture means? The substance which contains more than one component means that we can call as a mixture. Okay, solution is called as a mixture of components. Again, solutions are classified into two types. So how many types it is classified, Sirisha? Sirisha, solutions are classified into how many types? Kathy?
2 types, sir.
Two types. So what are the two types of the solutions? Kathy or Meenal? Meenal is telling that syllabus is completed. So middle, what are the two types of the solutions we are having? So Meenal, we have a homogeneous solutions and heterogeneous solutions. Okay, so what is meant by the homogeneous solutions means here? So the solutions which cannot be separated. So by seeing it look like as a homogeneous form that we can call as a homogeneous solutions. Heterogeneous solution means by seeing if you are observing two different layers or three different layers means that we can call as a heterogeneous solution. What are the best example for the homogeneous solutions means? Salt in water, that means sugar in water, salt in water are the examples of the homogeneous solutions. What are the examples of the heterogeneous solutions means? Salt plus oil, okay, and sand plus oil, soil plus water, oil, soil plus water. All these are the examples of heterogeneous solutions. Okay, and so here based on so now in 12th standard we are going to study about the binary solutions. In 12th standard, which type of solutions we are going to study means here? We are going to study about the binary solution. Binary means the solution which contains the two components. Okay, the solution which contains two components is called as a binary solutions. Okay, so here in two binary means here one is the solute, another one is the solid. So what is meant by the solute? Either Sirisha, Kathy, Meenal. What is meant by the solute, ma? Any one of you? Any one of you? Sai, Akshit, Khyati, Srisha. What is meant by the solute?
Sir, solute is something that you dissolve in the water or solvent.
Very good, Kathy. Very good answer. So we can give two different definitions for the solute and solvent. What is meant by the solute means the substance which dissolves in another substance is called as a solute. At the same time, quantity wise, if you check it out, means here you are preparing as a some sugar solution. In the preparation of sugar solution, we are taking as a 1 tumbler of the water. In that one, we are adding as a 2 spoons of the water. How much spoons of the water we are adding? Generally, we can add as a 2 spoons of the water. Na? Okay. In this one, quantity wise, if we check it out, means here sugar content it will be less and water content will be more here. So quantity wise also we can explain the solute and solvent. If you see quantity wise, the substance which is present in the lower quantity is called as a solute. The substance which is present in the higher quantity is called as a solvent. What is meant by the solute, ma? Solute is nothing but the substance which is present in the lower quantity is called as a solute. And the substance which is present in the higher quantity is called as a solvent. Okay. So these are the solute and solvent. Based on the solute and solvent, solutions are classified into total 9 types. Based on the solute and solvent, solutions are classified into 9 types. Total it is classified into how many types means here? It is classified into 9 types. Okay. So major classes. So majorly if you see means solutions are classified into 3 types based on the solvent. Major classes are 3 types. The total is 9 types. If the solvent is solid means here that we can call as a solid solutions. Okay. Already I gave the notes. Once again, it out. Here I had given yesterday. Right, ma'am. So these are the examples. These are the types of the solutions. All of you got the screen? Everyone. All of you got the screen or not, ma'am?
Yes, sir, we got.
You got the screen now?
Yes, sir.
Yes,
Okay. Now we can observe here. So based on the physical states of the matter, that means based on the solute and solvent, so solutions are classified into total 9 types. In that one, majorly it is classified into 3 types. So one is called as a solid solution and liquid solutions and gaseous solutions. So which we can call as a solid solutions means here. So when the solvent is the solid means that we can call as a solid solutions. Okay. And which we can call as a liquid solution means if the solvent is the liquid, if the solvent is liquid, that kind of solutions are called as a liquid solutions. And so gaseous solution, when the solvent is gas, that we can call as a gaseous solution. Okay, solid solution, liquid solution, and gaseous solution. So how they classify it means based on the solvent. Again, individually, if you see means solute, it may be solid, liquid, gas. According to that one, solutions are got as a total 9 types we got. Okay, these are the 9 types. Okay, so once I'll forward this one, I'll update in the form of PDF. Okay, in your app, just you go through this one. Okay, right. So next one. So solubility. What is meant by the solubility, ma? What is meant by the solubility? Any one of you? The Minal, Khyati, Srisha, Sayakshi. Minal, what is meant by the solubility, Minal? Come on, ma. Khyati?
Yes, sir.
What is meant by the solubility, ma?
It's the maximum amount a solute can dissolve in the solvent, I think.
Very good, ma. Okay, so what is meant by the solubility means the maximum amount of solute dissolved in a solvent is called as a solubility, ma, here. Okay, so based on the solubility, okay, again, so we have a dilute solutions and concentrated solution. What is meant by the dilute solutions means here, if the solute quantity is less in a water mean that we can call as a dilute solutions. Okay. If the solute quantity is more mean that we can call as a concentrated solutions. Okay. So based on that one, we are explaining some of the concentration terms. What are the concentration terms we are having means here? Weight by volume, weight by volume, volume by volume, weight by weight percentage, parts per million. Until that, yesterday we discussed. Today we are going to discuss about molarity. Today we are going to discuss about here molarity. So how many members you know about the molarity? Molarity. What is meant by the molarity? What is meant by molarity? Any one of you?
Sir, I say,
What is meant by the molarity, Mina?
the number of moles of solute present in 1 liter of solution.
Very good, Minal. Okay, so what is meant by the molarity means here? So molarity is nothing but number of moles of solute present in 1 liter of solution is called as a molarity. So what is meant by the molarity means here? Molarity is nothing but number of moles of solute present in 1 liter of solution. This also we can write as a number of moles of solute present in 1 liter of solution. 1 liter of solution. Okay. Here we are talking about the mole. So what is meant by the mole, ma? How we can represent the number of moles here? Number of moles can be represented. Actually, molarity can be represented with capital M. This also we can write capital M is equal to N divided by V in liters. V in liters. Okay. In this one, N is represented as a number of moles. How we can calculate the number of moles? Any one of you?
So given mass by molar mass.
Mama. Number of moles means given mass by molar mass. So number of moles is equal to given mass by molar mass. Given mass by molar mass here. Okay. Molar mass. So this also how we can represent means here. So here weight by gram molecular weight. Gram molecular divided by. So V in liters. So this also we can simplify now. So how we can write means here M is equal to weight by molecular weight into. So if you take weight in grams means that time volume also we have to take it in ml formation now. So whenever you take it in ml formation means how we can write the equation means molecular weight is equal to weight by molecular weight into 1000 divided by V in ml. V in ml formation. Now you got the clarity, all of you. So how we can represent the molarity means here. Okay. And what are the units of the molarity?
Sir, a mole L inverse or mole per liter.
Mole liter inverse. Okay. So how we can write the units of the molarity means here? Units of the molarity is equal to mole liter inverse. Now you got the clarity. Okay. So based on that one, we have some different formulas which are related to the molarity. Okay. Sometimes they're asking the questions in the examination pattern or examination also. JEE exam also they're asking the question based on the molarity, normality, and at all. Okay. At the same time, in 12th standard, you have an acid-base neutralization. You have an acid-base neutralization. That means you are doing the volumetric analysis. I don't know how many members you had done the practicals or not. I don't know. Okay. Actually, volumetric analysis means acid-base neutralizations are there. And 12th standard, we have a KMN4 versus oxalic acid and KMN4 versus more salt one experiment is there. There also we are doing some calculations. All that calculations done based on here molarity only. Okay, and we can find out the resulting molarity. Okay, dilution is there. So and the resultant molarity, some formulas are there here. Okay, so what are the formulas? Shall we see some different formulas? Okay, so what are the different formulas we can see means here? First, let us see. First of all, acid-base neutralization. First, acid-base neutralization. Acid base neutralization. So what is the formula we can use for the acid base neutralization? So M1V1 is equal to M2
M2B2.
V2 by N1 by L2 here. So this is the formula we are using to calculate. We are using in the calculation of acid base neutralization. Okay, and in this one, some data is there. If we know three terms, any three terms means either it may be two molarities and volume. Okay, we can calculate the another volume also. Okay, so comparable values also. Let us see two different. M1 V1 is equal to M2 V2 formula. Okay, so this formula also we can use to calculate the concentration or volume also. How we can calculate means if you know any of three terms, if you know any of the three terms means we can use as the we can calculate the fourth one. Na? We can calculate or not? Aditi, if you know any
Yes,
of
sir.
three means we can calculate the fourth one or not?
Yes, sir.
Okay, so this is the one formula we are using. At the same time, two different concentration of the solutions, same solutions are there. For example, 1 molar HCl is there. Okay, 1 molar of. Okay, let us see, ma. So I will ask one question here. So 1 molar of 250 ml of 250 ml of HCl is mixed in. So 2 molar of 500 ml of HCl. Okay, or 750 ml we can take one. How much one here? 750 ml. We can take as a 750 ml of HCl. So what is the resulting concentration of the HCl? What is resulting concentration of HCl? How we can calculate the resulting concentration of the HCl from this one? What is the formula we can use here to calculate the resulting molarity? Okay, to calculate resulting molarity. So what is the formula we can use means here? So M1 V1 plus M2 V2 by V1 plus V2 is the formula. So this is the formula we can use to calculate the resulting molarity. So resulting molarity can be represented with the MR. So how we can represent here? So resulting molarity can be represented with here MR. So MR is equal to M1 plus M2. So V1 plus V2 is the formula. Okay. So according to the one, what is the answer for this one? Any one of you?
So 1.75.
1.75, yeah.
75.
Mobile ke pura?
We look at as a 1.75 man. So M1 V1 value it becomes as a 250 ml. Okay. Plus and M2 value. So M2 value is
So it will be
so
2 into
750.
750 there.
2 into 750 divided by so V1 V2. So V1 V2 is V1 value is 250 plus V2 value is 750. So is equal to how we can write 250 plus 1500 divided by you will get as 1000.
Yeah, so then
Okay.
we'll get it as 1750 divided by 1000, which is 1.75.
Very good. Pa. So what is the molarity means? 1.57 is the 1.75 is the molarity. Okay, so now understood here all of you. So how to calculate the resulting molarity and what all means here? Resulting molarity can be calculated. The formula is M1 V1 is equal to M2 V2 by so V1 plus V2 is the formula. Okay, if they had given some different solution. So now either it may be acid or base. Both are identical one means that time only we have to use this formula. All the time we cannot use as a this formula. Okay. So next. So two different solutions. If acid or base they had given. Okay. If two different solution means how we can write the formula result to calculate the resulting molarity. Okay. For two different solutions. Okay. If we are having two different solution for two different solution for two different solutions. Okay, so what is the formula we can use means here? Resultant molarity is equal to M1 V1 minus M2 V2 by, so V1 plus V2 is the formula. Okay, sir, which one we have to consider as a M1 V1 means here the value, so the molarity and volume. So greater the value, the product which will be greater the value means that we have to consider as a M1 V1. Okay, what is the lower the value? It is that we have to consider as a M2 V2. Now, do you understand here? For example, acid they had given. Acid concentration is more means that we have to consider it as a M1 V1. Otherwise, if the base concentration they had given as a greater value means that we have to consider it as a M1 V1. Now you got the clarity, all of you? All of you got the clarity?
Yes, sir.
Okay. So then, so which formula is represent as a relationship between? So which of the following formula is represents the relationship between density and molarity? What is the formula we can use? Density and molarity. What is the formula? Which formula it is that to explain the density and molarity? Molarity is equal to X percentage into D into 10 divided by molecular weight of the solute. Molecular weight of the solute. In this one, what is the X percentage? X percentage is nothing but it is here weight by volume percentage. Okay, so what is the X percentage means here? X percentage is nothing but weight by volume percentage. Okay, so now you got the clarity here. So the given formula it represents as a relationship between the molarity and density. Okay, so now I'm going to ask the previous year mains question. Mains question they ask here. So one formula it is that. So which of the following formula is represents the relationship between the molarity and density? Three terms are there. Which of the following formula is represents the relationship between the molarity and density? So what is the formula means here? Molarity is equal to molarity into 1000 divided by, okay, so 1000 divided by, so D into 1000 minus of molarity into molecular weight. This is the previous year question. So based on this one, they asked the question also, calculation question also they asked. Which of the following formula is represents the relationship between molarity, density? Okay, clear? Still anyone you having doubt here? All of you got the clarity?
Yes, sir.
Yes, sir.
Okay. All these formulas are very, very important. If you learn all these formulas only, then only calculations are becomes as easy. Okay. So you all are JEE students. So JEE students means compulsory calculations you have to be do. Okay. And that is also most of the questions they are giving as a formula oriented questions in the JEE examination. If you don't know the formulas means it is very difficult to do the calculations in the examination part. Okay. So next upcoming Sunday, so you are having the test based on this one. Okay, so then, so we'll go for the molality. So because of we got some molality term. So what is mean by the molality? Now we had seen molarity until here we had seen as a molarity. Then what is mean by the molality? Any one of you?
So number of moles of solute by mass of solvent in kg.
Very good. Okay. Aditi, come again. Molality can be represented with small m. Okay. How we can define the molality, Aditi?
So number of moles of solute divided by mass of
Hmm.
solvent in kg.
Kg. Very good, Aditi. Okay. How we can define the molality means here number of moles of solute present in 1 kg of the solvent and divided by 1 kg of solvent. 1 kg of solvent. Number of moles of solute present in 1 kg of the solvent. Then how we can write the units of the molality? So
So
moles
mole
per
kg
kg.
inverse.
Mole kg inverse we can write as here. So how we can write the, so units of the molality means molality of the units we can write as a mole kg inverse. So this formula also we can simplify. M is equal to weight by, so gram molecular weight into, so 1000 divided by, so weight of the solvent, weight of the solvent. Okay, so this formula is very important, my friend. Okay, so why it is this formula is very important means here. Now in this chapter we have an important concept. What is the important concept we are having means qualitative properties are there. In this chapter we are going to study about the qualitative properties. So in qualitative properties everywhere we are taking as a molality only. Okay, so molarity is nothing but can call as a molar solution. Okay, and molality also we can call as a molar solution. What is meant by the molar? They are using some term to make you confused. Molar is different and molar is different. Molar is represent as a molarity and molar is represent as a molality. Okay, I got it here. So molality is equal to weight by the molecular weight into 1000 by weight of the solvent. Okay, still anyone here having doubt here? Okay, and one more formula also it is there, so which is related to the molality. So what is meant the another formula which means here molality is equal to xb into 1000 divided by xb into 1000 divided by xa into MA. In this one, MA is nothing but molecular weight of the solvent. In this one, XP is nothing but mole fraction of the solute. Mole fraction of solute. Okay. In this one, XP is nothing but we can write as a mole fraction of solvent. Mole fraction of the solvent. Sorry, XA is nothing but mole fraction of the solvent. Okay. And MA is nothing but molecular weight of the solvent. MA is nothing but molecular weight of the solvent. Molecular weight of solvent. Okay. So now you got the clarity, all of you. So the same formula also to make you clarity, we can write in another formation also. So how we can write the another formation means here, molality is equal to 1 minus XA into 1000 divided by XA into molecular weight of the solvent. Sir, why you are writing as a 1 minus XA means here? According to the mole fraction concept, XA plus XB is equal to 1. Okay. According to that one, in place of XB, what we can write? XB is equal to 1 minus XA also we can write now? We can write or not?
Yes, sir, we can.
Okay. So according to the mole fraction concept, XA plus XB is equal to 1. Then XB is equal to 1 minus XA. So in place of XB also we can write as a 1 minus XA we can write. Okay. So next, in this one, now what is meant by the mole fraction? Next concept is mole fraction. What is meant by the mole fraction? Mole fraction. What is meant by the mole fraction? All these are the concentration terms only. Mole fraction. Based on that one, we have so many numericals. We can solve the so many numericals. Actually, mole fraction can be represent chi. Okay, chi somebody they call as a chi, somebody they call as a x also. Okay, so chi mole fraction can be represented with the chi. So chi is equal to or x is equal to number of moles of one component. Number of moles of one component divided by total number of moles of components. Total number of moles of components. Components. Total number of moles of components. Okay. Now in this one switch we don't know. So we are talking about the binary solutions now. Binary solution means how many components are there in a solution? In
Two.
binary solution,
Two,
two
sir.
components are there. So what are the two components means? One is called as a solute, another one is called as a solvent. Number of moles of solute can be represented with, okay, number of moles of solute can be represented with NB. Number of moles of the solvent can be represented with Na. Okay. Now we want to calculate the mole fraction of the solvent. That means mole fraction of the solvent Xi is equal to, we can write as a number of moles of the solvent by number of moles of the solute plus solvent. So this is the formula we are writing. Okay. And if you wanna write the formula for the Xb value, how we can write the formula for mole fraction of the B? Mole fraction of the solute.
NB divided by Na plus NB.
NB divided by
Na plus
plus
NB.
NB. Okay. So in this one, XA plus XB is equal to 1 mark. If you know mole fraction of the A means from that one we can calculate the mole fraction of the B. Okay. Otherwise, if you know the mole fraction of the XB means by using this value we can calculate the mole fraction of the XA also. Now you got the clarity. Okay. Now,
Yes.
okay. So last one. What is the last concentration term we are having means normality. Normality. So what is mean by the normality? So this is very, very important concept here. Normality. What is mean by the normality? Who's going to define the normality? Normality can be represented with capital N. So how we can define the normality? How we can define the normality? Normality is defined as number of equivalents of solute, number of equivalents of solute present in 1 liter of solution. Present in 1 liter of solution. Okay, so normality is nothing but here. So number of equivalents of the solute present in 1 liter of solution is called as a normality. Now in this one, so how we can calculate the number of equivalents, ma?
So given mass divided by equivalent mass.
Number of equivalents, ma?
So given mass divided by equivalent weight.
Given mass by equivalent weight. So number of equivalents can be calculated. Number of equivalents is equal to given mass by equivalent mass. Okay, so in this one, how we can calculate the equivalent mass?
So molar mass by n factor.
Equivalent mass is equal to molar mass by n factor. Okay, so here how we can calculate the equivalent weight means equivalent weight is calculated by molar mass by n factor. Okay, in this one, what is meant by the n factor? N factor we may write as a acidity, basicity, and number of electrons transported in a chemical reaction. Number of electrons transport in chemical reaction. The highest charge in the cation or ion. So in salts, highest charge. Okay, highest charge.
Valency.
Okay. So valency also we can take. Okay. So if we know the n factor, then only it is possible to calculate the equivalent weight. Okay. So if you simplify the formula, normality, if you simplify means how we can write means normality is equal to, if you simplify means here. So given weight by equivalent weight into so 1000 divided by V in ml. Okay, so V in ml. So what are the units of the normality means here? Equivalence and liter inverse. Liter inverse is the units of the normality. Okay. Now, so based on this one, now I'm going to ask some question. Now, until here, we had seen some of the concentration terms. Na? Okay. Now, so we had seen the molarity and we had seen the mole fraction. We had seen the molality and we had seen the normality. So which of the following concentration terms are depends upon the temperature? Which of the following concentration terms are depends upon the temperature? This is the previous JEE question. Aditi or Kathy, Sirisha. How many members are there today? Today total 6 members. I'm really very happy. Okay. So Meenal, so what is the answer? So which of the following concentration terms are depends upon the temperature? That is my question.
So normality and morality.
Molarity, ma. Very good, Aditi. So normality and molarity or depends upon the temperature. Sir, how you are telling that means here according to the state
So
of matter.
because the denominator
Charles law. According to the Charles law, volume is directly proportional to the temperature. If the temperature is going to be changes, means volume also is going to be temperature. Volume also is going to be changes. So due to that reason only molarity and normality are. So we are taking as a volume. Okay. So which of the following terms are not depends upon the temperature? Independent on the temperature. Which of the following concentration terms are independent on the temperature? Sirisha.
So molality.
Molality and mole fraction. So which one means here? Molality and mole fraction. Okay. So in next class, we will solve some question. Previous JEE questions we are going to be solved based on these concepts. Okay. So shall we continue in the next class?
Yes, sir.
Thank you all. So
Thank you, sir.
Thank you all. Everyone, you understood now?
Yes, sir.
Meenal,
Yes,
Kathy.
sir. Yeah, understood, sir.
Very good. Very good. So then we'll continue in the next class. So thanks a lot, everyone.